Good day, sir. I'm John Albert Asuncion, and this is my video presentation about the topic 2, the task 2, which is the process of vapor. So I started answering the problem at the number 5. So number 5, the problem is steam at 3.1 MPa and with 74.28 degrees Celsius. SH reject 1973.36 kilojoules per kilogram of steam. Heat at constant pressure. Determine the final temperature and the change in specific entropy. So the given is P1 is equals to 3.1 MPa. The T saturated is equals to 235.692 degrees Celsius. T1 is equals to 236.692 plus 74.28 is equals to 309.972 degrees Celsius. And the Q range, which is equal to 1973.36 kilojoules per kilogram. So the required to answer is the final temperature of the steam, change in entropy, and the final temperature of the steam will be the saturated temperature corresponding to 3.1 MPa minus T sub 2 is equals to 235.692 degrees Celsius. So from the steam table, at 3.1 MPa and 309.972 degrees Celsius, the H1 is 3014.78 kilojoules per kilogram. The S sub 1 is equals to 6.5795 kilojoules per kilogram minus K. And the Q reg is equals to H1 minus H2. So to find the H2, let's substitute the following. The Q reg is equals to H2 minus H1 minus H2. So the Q reg is 1973.36 is equals to the H1, which is 3014.72 minus H2, and the value of H2 is 1041.42 kilojoules per kilogram. From the steam table corresponding to 3.1 MPa, HF is equals to 1017.04 kilojoules per kilogram. Hg is 2804.1 kilojoules per kilogram. The SG is equals to 6.1869 kilojoules per kilogram minus K, and the SF is equals to 2.6456 kilojoules per kilogram minus K. So to find the X sub 2, we must use the formula H2 is equals to HF plus X2 multiplied by Hg minus Hf. So substitute the this formula into the given. So the value of H2 is 1041.42 kilojoules per kilogram is equals to Hf, which is 1010.25 added by X sub 2 multiplied by 2000 multiplied by Hg, which is 2804.1 minus Hf, which is 1010.25. So the value of X2 is equals to 0.0174 So we must find the S2. So to find the S2, we must use the formula S2 is equals to SF plus X2 multiplied by SG and minus SF. So S2 is equals to SF, which is 2.6456 plus the X2, which is 0.0174 multiplied by SG, which is 6.1869 minus SF 2.6456. S2 will give us 2.71 kilojoules per kilogram minus K, and for the solution for the change of entropy, we must subtract S2 minus S1. So our S2 is 2.7071 kilojoules per kilogram minus K minus the S1, which is 6.5795 kilojoules per kilogram minus K, and the change of entropy will give us negative 3.8724 kilojoules per kilogram minus K. So I will proceed to the number 7. So the problem for number 7 is a rigid vessel contains 5 kg of wet steam at 0.4 MPa. After the radiation of 9,585 kilojoules, the steam has a pressure of 2.0 MPa and a temperature at 700 degrees Celsius. Determine the initial internal energy and the specific volume of the steam. So, at steam table, at 2.0 MPa and 700 degrees Celsius, the value for B2 is 3,470.9 kilojoules per kilogram. To solve for the V1, we must use the formula Q is equals to V2 minus V1. So Q is equals to 9,585 kilojoules divided by 5. So the value for Q is 1,917 kilojoules per kilogram. Negative V1 is equals to Q minus V2. Negative V1 is equals to 1,917 kilojoules per kilogram minus the value for V2, which is 3,470.9 kilojoules per kilogram. The value for V1 is equals to 1,553.9 kilojoules per kilogram. To solve for the V at the 0.4 MPa, VF1 is equals to 0.00100836 m cube over kilogram. VG1 is equals to 0.4625 m cube per kilogram. VF1 is equals to 604.31 kilojoules per kilogram, and the VFG1 is equals to 1,149.3 kilojoules per kilogram. So to find the X, we use this formula as X equals to V1 minus VF1 over VFG1. So the X equals to the value of V1, which is 1,553.9 kilojoules per kilogram, minus the VF1, which is 604.31 kilojoules per kilogram, divided by the VFG1, which is 1,949.3 kilojoules per kilogram. So the value for the X is 0.487. To find the specific volume for the steam, we use the formula V1 is equals to VF1 plus X VFG1. So V1 is equals to the value of VF1, which is 0.0010811, plus the X, which is 0.487 multiplied by VFG1, which is 0.4625 minus 0.0010811, and the specific volume of the steam is 22,258 m³ over kilogram. So I will proceed to number 9. So the number 9 problem is water at 2.5 MPa and 200 degrees Celsius is heated at constant temperature up to a quality of 40%. Find the quality of heat received by the water, the change in internal energy, and the work of the non-flow process. So the given in this problem is P is equals to 2.5 MPa and the temperature is 200 degrees Celsius. The water heated up the quality of 80% is equals to 0.8. From the steam table for compressed water, properties of water at 2.5 MPa and 200 degrees Celsius, the H1 is equals to 852.775 kilojoules over kilogram, and the V1 is equals to 879.886 kilojoules per kilogram. From the steam table for saturated water, the properties of water at a temperature 200 degrees Celsius are HF is equals to 852.26 kilojoules per kilogram. The HFG is equals to 1939.8 kilojoules per kilogram. The VF is equals to 850.46 kilojoules per kilogram. And the VFG is equals to 1743.7 kilojoules per kilogram. So the final enthalpy of water is H2 is equals to HF plus X multiplied by HFG. So the solution now is H2 is equals to HF, the value of HF, which is 852.26, plus the value of X, which is 0.8, multiplied by the HFG, which is 1939 minus 8, will give us 2404.1 kilojoules per kilogram. So the quality of heat received by water, so the solution is Q is equals to H2 minus H1. The Q is equals to 2404.1 minus the value for H1, which is 852.775. So the value for Q is equals to 1551.325. For the final internal energy of water, the formula is V2 is equals to VF plus X multiplied by VFG. So V2 is equals to VF, the value of VF is 850.46, plus the X, which is 0.8, multiplied by VFG, which is 1743.7, will give us the 2245.46 kilojoules per kilogram. For the change in internal energy, delta V is equals to V1 minus V2 minus V1. So delta V is equals to, the value for V2 is 2245.46, minus the value for B1, which is 849.886. So it will give us 1395.574 kilojoules per kilogram. For the work of non-flow process, the Q is equals to delta V plus delta W, which is the work. So delta W is equals to Q minus delta V. So the value for Q is 1551.325. Muna ang gin-solve ta dito for the Q. Then minus siya sa delta V na bago lang ta solve, which is 1395.574. So the work for non-flow process is 155.751 kilojoules per kilogram. We will proceed to the number 10. So the problem in number 10 is 3 kilograms of steam initially at 2.5 MPa and a temperature of 370 degrees have 2,460 kilojoules of heat removed at constant temperature until the quality is 90%. Determine the pressure when dry saturated steam exists and the work. So the given in this problem is P1 is equals to 2.5 MPa, T1 is equals to 370 degrees Celsius, QR is equals to 2,460 kilojoules, and the X is 90% or 0.9. So as a temperature in a constant, and finally it comes under the wet condition, P2 is equals to P saturated. From the steam table, P2 is equals to 21.035 MPa. At the initial condition of V1 is equals to 2,890.6 kilojoules per kilogram, and the final condition of P2 is equals to Vf plus X Vfg. So the value for Vf is 1,840.2 plus the X, which is 0.9, multiplied by Vf is 2,230.2 minus 1,840.2. So the V2 is equals to 2,191.2 kilojoules per kilogram. Using the first law, or for looking for the work, Q is equals to delta V plus delta W. So the value for Q is equals to 2,460, negative 2,460 is equals to 3 multiplied by 2,890.6 minus 2,191.2 plus work. So the value for the work is negative 4,558.2 kilojoules. So now I will proceed to the number 11. So the problem for the number 11 is the 3 kg of steam has an initial enthalpy of 7,200 kilojoules at 0.145 MPa. Isentropic compression gives a final pressure of 0.2 MPa. Find the initial and final temperature and the work of the steady and non-flow process. So the given this problem is H1 is equals to 7,200 kilojoules, P1 is equals to 0.145 MPa, P2 is equals to 0.29 MPa, and the mass is equals to 3 kg. From the steam table, the saturation temperature corresponds to the given initial pressure is T1 is equals to 110.336 degrees Celsius. So the change in entropy delta S equals to Cp T squared over T1 minus R in P2 over P1. So 0 is equals to 1.87 ln 72 over 383.34 K is equals minus 0.461 multiplied ln multiplied by 0.29 over 0.145. T2 is equals to 4. T2 is equals to 454.77 K. So from the steam table, the enthalpy corresponds to the final state. So the H2 is equals to 2822.62 kilojoules per kilogram. The steady work done, WS, is equals to H2 minus H1, or WS equals to M H2 minus H1. So for this equation, WS is equals to mass, which is 3 kg, multiplied by H2, which is 2822.62 kilojoules per kilogram, minus the H1, which is 7,200 kilojoules, will give us 1,267.87 kilojoules. For the non-flow work or closed system work done process is given by work is equals to MR multiplied by T1 minus T2 over T plus 1. So the work is equal to the mass, which is 3 kg, multiplied by R, which is 0.461 kilojoules per kilogram, multiplied by T1, which is 383.34 K, minus T2, which is 454.77 over the T plus 1, which is 1.33 minus 1. So the work done is equals to 299.36 kilojoules.